So now in this particular video we'll be covering up circular convolution using graphical method, and we are dealing with the same problem, that is x of k is 1 2 3 4 and h of k is 1 3 5 7, and your y of n resultant should be 42 46 42 and 30, which is the result of the circular convolution. This being the graphical method, we have to solve this problem using diagrammatic concept, and in adherence to that, this is also known as a concentric circle method, and we'll start off with the method right now. So as a start, for representing these two signals x of k and h of k, we have to draw two concentric circles, and one representing, so let's assume this represents x of k and this represents h of k. So we draw two circles representing the two signals, and each of these signal has four components, so we mark 4 points designating the components over here. So I have a typical logic that works out over here. So x of k is basically drawn anti-clockwise. That is the inner circle x of k will be drawn anti-clockwise, and if this is a starting point, this will be x of 0, this will be x of 1, this will be x of 2, and this will be x of 3. So this represents 4 points 1 2 3 4 in this graph, x of 0 being 1, x of 1 being 2, x of 2 being 3, and x of 3 being 4. Now this same concept can be applied for the outer circle also, where it will represent 4 signal components here. Now the outer circle x of k will be drawn in the clockwise manner. So if you remember the operation about convolution, if you look at the kind of operation that was there in the linear convolution graphical method, you would know that x of k, a normal signal, was operated upon the folded version of h of k. So which is why if x of k in a normal way, if it is drawn in the anti-clockwise manner, we draw h of k in the clockwise manner, indicating it is equivalent to h of minus k. I hope that point is clear. So then this becomes h of 0, this becomes h of 1, this becomes h of 2, and this becomes h of 3. So to calculate y of 0, the x of k will be operated with h of minus k. The same operation, the logic will be like this. So what would happen here is we have x of k drawn in the normal manner, and h of minus k is also drawn in this particular format. So both the circles are ready. All you need to do is multiply these element by element. So h of 0 is 1, h of 1 is 3, h of 2 is 5, and h of 3 is 7. So when we multiply element by element, it becomes 1.1, then it becomes 2.7, then it becomes 3.5 plus 4.3, which makes it 1 plus 14 plus 15 plus 12. So it becomes 15, and 15 plus 15 is 30, and 30 plus 12 is 42, which is the first term here. Now this signal, to calculate y of 1, this signal x of k must be shifted in one position. So typically it will be written as x of k is operated with h of 1 minus k. So what would it basically mean is the fact that it has to operate with the shifted version of h of minus k. So what we do here is, to shift it one step, we'll be rotating this in the anti-clockwise manner. So h of k or h of minus k will be rotated in the anti-clockwise manner. So again, if we draw the two circles, let's see how it works. So to draw the second version or the second diagram for computing y of 1, so in order to compute for y of 1, we have to mark the same position. So just like in linear convolution, x of 0 remains in this, x of k remains in the same position without any change. So we draw it in the anti-clockwise manner. X of 1, x of 2, and here you have x of 3. So this becomes 1, this becomes 2, this becomes 3, and this becomes 4. So this becomes 1, this becomes, and we have to draw the signal on the outer graph which corresponds to h of k. Now if such a signal is to be drawn, we are going to rotate it in the anti-clockwise manner. So if that is the case, and rotating this in the anti-clockwise manner, so this becomes h of 0, this becomes h of 1, this becomes h of 2, and this becomes h of 3. So h of 0 is 1, h of 1 is 3, h of 2 is 5, and h of 3 is 7. So to compute y of 1, we have to draw or calculate the elements as mentioned before. So it will be like 1.3 plus 2.1 plus 3.7 plus 4.5 multiplication. So 3, 2, 21 and 20. So it becomes 5 plus 41 equal to 46, which is again the second element that is shown here. So moving ahead, shifting each of these component, we'll be getting the desired outputs. So rotating the output circle or the outer circle one more time, we get it as y of 2. Another time we'll be able to compute y of 3, and another time it will return back to the original state that was shown here as part of this first diagram. So hence the output will be cyclic and it will be periodic over that duration of 4 to keep repeating over and over again, and hence this thing is known as the periodic convolution. So if you're clear with this concept, I think this particular topic should be clear. Using this shift operation 2 more times, we'll be able to calculate y of 2 as well as y of 3, which would be the answers that are mentioned above, that is 42 and 30, and you should be able to complete your problem with this particular thing. So what we have completed here is the circular convolution graphical method.